Good morning, class. Remember, I promised that we will continue with this problem that I was doing the other day. So far, we've calculated the position of our second moment of area or moment of inertia. We said from the lower part of the beam, this is the position. That is the distance from the bottom to where we have IXX. If you look at that dimension, that is 350, so 391, let's say it's going to be somewhere there. And from the top is 258. So if this is 300, half of 300 is somewhere there, which is 150. 258 will be somewhere there. So this is the position. 258,33. Then from the bottom is 391,67 millimeters. This is the position of axis. The question is now, what about y? Y from the right is 283. So I'm looking at this dimension here is 300. This is the right hand side. I've explained that is 300. So 283 is somewhere here. From there to there is 283. From there to the far left is 416. So 400 is the distance, because from there to there is 300. So if I subtract 300 from 700, then I'm left with 400. So that distance there is 400. So 416 is going to be somewhere there. You don't have to be exact, guys, but at least it might make sense when you are plotting those x left and those x right. It must make sense, because if it doesn't make sense, so you're going to have a problem when calculating your IXX and your IYY. So your 283,33 and then your 416,67 millimeters. Please, guys, take notes if you have questions. Don't give up and stop watching the videos. Just take notes of all your questions, and please do not attempt tutorial questions without going through the worked example that we are doing together here in class. Once you do that, guys, I am telling you, I promise you, you're going to face problems and you're going to complain and you're going to have attitude towards the module. Then at the end of the day, only to find that you are the one that is creating those problems by not going through the worked example, so that you grasp the concept. Once you grasp the concept, then everything is going to be a bit easy for you. It's then that you can go to the tutorial question. This is the center of this. So if this problem is trying to rotate, at this point is a center. If you put a pin there, you put the problem on top, then you're there. That is a center. At this point it won't rotate. It won't rotate to the left or right. This is the center of this section. Okay, so remember that. So we've got the position of y, we've got the position for x. The only thing that now we need to work out is the magnitude. I did mention from the previous video that the position we refer is as first moment of area. It's the moments but using the area. As I was saying, remember when we were calculating y lower and y upper, we were taking moments, to be honest with you. You would say I'm taking moments about the bottom there. So you use the area and the distance from the center of that area to there. That is a moment, but using areas. That's why we said first moment of area. So this one that we're doing now is called second moment of area, or is called moment of inertia. So how do you do that? Let's start off by calculating Ixx. I think from the section properties that section properties that I emailed you, you will see this formula that I'm going to write here. Ixx is equal to Ixx, I'm gonna say prime. What is Ixx? Is Ixx for the individual section. So we've got two sections here. Area 2, section 2, you've got section 1 here. So it's Ixx for section 1 if I'm focusing on that, and Ixx for section 2 if I'm focusing on area number 2, plus AC squared. That is the formula to calculate Ixx for the entire section. So I will do this for area number 1, and then I will do the same thing for area number 2. Luckily in this case you don't there's no opening or anything else, then straightforward addition of the Ixx is for the areas. Area, this is your cross-sectional area. C is the distance from the center of the area in consideration to X, because I'm calculating Ixx. I will show you just now. So let's look at area 1. So I must write it down again. This is for area 1 plus this is for area 2. This one is for area 1, but I ran out of space first, and this one is for area 2. So what is Ixx? For a rectangular section, I know that Ixx is BD cubed over 12 plus AC squared. Okay. What is B? Which area? Area 1. B is 300. The depth is 350. There's a depth there for area 1. It's 350 cubed all over 12 plus what is area 1? It's 105 times 10 to the power 3. Sorry guys, I'm sorry, you can't see. It's 105 times 10 to the power 3 times. I'm going to leave C for now. Then I'm going to come back to that plus. Remember, I still have to substitute that C there, but I'm going to come back to that. Then I'm going to area 2, guys. Remember, B for area 2 is 700, D is 300. So B D cubed over 12, so it's 700 times 300 cubed over, so 12, plus the area is 210 times 10 to the power 3. Then I substitute C there. So remember I said to you now let's sort out our C's now. Our C. I'm looking at area number 1. I know the distance from there to there. I know that distance. That distance is half of 350. 350 divided by 2 gives you 175. I hope I'm right. It's half of that. So if you take out now from my y lower, remember from there to there, it's my y lower. So the distance that I need is this distance. This is the distance, I call it C1, because it's the distance from the center of area 1 to X. So what is C1? So I'm going to take my y lower, subtract this distance, then I'll be left with that distance. Let me just do that. Okay. So 391,67 minus 175. That gives me 261,67. That is my C value, sorry. That is my C value for area 1. I took my y lower, I subtracted the distance from there to there, then I'll be left with that distance. That gave me my C for area 1. Let's look at C for area 2. Remember, this is all area 1. Let's look for C for area 2. I'm going to take my y up. I know the distance from there to there is half of 350. That distance, the distance from the center of that area to there is half of 350, which is 300, which is 150. Half of 300, which is 150. So this is the distance I'm looking for. I call it C2. The distance from the center of this area to where I have my IXX, because I'm calculating IXX. Hence it's important, guys, to get the position of your IXX correct, because if you have got position of your IXX and your IYY are incorrect, that means your C values will be incorrect. Even if you understand the concept, but you got them incorrect, then your C values will be incorrect. So I'm going to take this now, I subtract the top one, and then I'll be left with C2. So 258.33 minus 150 gives me 108.33. Squared, because this is AC squared. I've seen students making a mistake forgetting that squared, then obvious is going to be incorrect. So let's do it. 300 times 350 cubed divided by 12 plus 105 exponent 3 times 261,67 squared. That is, I'm done with that. Then I'm doing this one now. 700 times 300 cubed divided by 12 plus 210 exponent 3 times 108. I hope 108.33 squared. Then I close my bracket. Then this is my answer that I'm getting from the calculator. But watch this. To me, as an engineering person, this doesn't make sense. 10 to the power 3, these are, it makes sense. 10 to the power 6 makes sense. 10 to the power 9, 10 to the power 12, it makes sense. Then if I press ENG to my calculator, then it's converting them to the proper engineering format. So this is 12,302 times 10 to the power 9 millimeters to the power 4. Those are the units for IXX and for IYY. This one is the magnitude. It is a magnitude, and then the units is that. You can see here, this is millimeter to the power 3. This is millimeter. So millimeter to the power 3 times a millimeter will give you your millimeters that will refer to the power 4. Even if you look at this one, this is an area in millimeters squared. This one is a distance, but I'm squaring that distance, so it's going to be in millimeters squared. Millimeter to the power 2 times millimeter to the power 2 will give me millimeter to the power 4. So here I've got the magnitude of my moment of what? Of my moment of inertia. If you have noticed there, I'm using an area there, I'm multiplying by distance. That means again I'm using moment of area, but it's a second moment of area. It's a second moment of area. Okay, now let's look at IYY. Let me just take another piece of paper. Just give me a second, guys. Okay. IYY. I'll just put it on top of this, guys, if you don't mind. I'm now calculating IYY. So IYY, exactly the same way that we're calculating IXX, is equal to IYY plus AC squared for area 1 plus IYY plus AC. This is for area 2. Okay. Now, what is IYY? Is dB cubed, or is dB cubed all over 12 plus AC squared. dB cubed all over 12 plus AC squared. That is my IYY. D for area 1 is 350. B is 300 cubed all over 12 plus the area for area 1 is 105 times, I'm gonna skip it, I'll substitute C at a later stage, and then I'll go to D for area for area 2. Remember, D for area 2 is 300, B is 700 cubed all over 12 plus the area is 210 times 10 to the power 3 times the C value. Okay, let's compare the two now. What I did with IXX. 300. Look here now. It was 300 cubed. Now, sorry, it was 350 cubed. Now it's 300 cubed. I hope you can see it, guys. Sorry. It was 300 times 350 cubed. Now it's 350 times 300 cubed. Or you can say 300 cubed times 350. If you don't, I just swap them around. You can say 300 cubed times 350 over 12. The area is still the same area. The only thing that is going to differ is your C. Same applies here. Here it was 700 times 300 cubed. Now I've got 700 cubed times 300, or 300 times 700 cubed divided by 12. The area is still the same. So I'm looking now at my C values. Remember now we're looking at X, so I want the distance from here to there, that distance. This is the distance I refer to as what? As C. That's causing the moment, that's causing this section to rotate. So to get that distance, I know that distance is half of 300. This is 150. So if I take my X right, I subtract 150, then I will be able to get this distance. That is for area 1. So my X right being 283.33, I subtract 150, which is half of 300, minus 150. That gives me 133.33. That is my C value, 133.33, which is 283.33 minus 150. Then I'll be left with that distance. Same thing that I'm going to do with X with area 2. I know that distance from the center there to the end. That one is half of 700. That means it's 350. So I know the distance from there to there, to the center there, to where you've got I. That distance is 416. So if I take 416 and subtract 350, then I'll be left with this distance that I call it C2. That is for area 2. So 416.67 minus 350 gives me that distance, which is 66.67. 66, let me just take it up so that you can see, 67 squared. Don't forget the square. Then what do you do after that? Remember, up to there is for area 1, that one is area 2. What do you do after that? You just punch your calculator. Again, it's giving me this, guys. So I don't expect a student to give me this answer, guys. If you are an engineering student, expect it to change it to proper. It's 12.16 times 10 to the power 9 millimeter to the power 4. So guys, that's how you're going to calculate the second moment of area for any sections. Remember now, the only difference that you're going to get is that some sections there will be an opening. That the only difference is that if, for example, I have this problem, the very same problem, and I'm telling you that here there's an opening. Yes, you will divide it the normal way. You will divide it that way. Then you will have this area being area 1, this area being area 2, the opening you give it, you say is area 3. You do it the same thing, you work out your position, but remember, when working out your y lower and your y upper, then it's going to be area 1 times whatever distance, area 2 times whatever distance, and then minus area 3 times whatever distance. But we will do a problem like that, not now, definitely not now, but at least for now I want you to digest what we've been doing here. If you have any problems, feel free to contact me, guys, via WhatsApp or on Teams. And whenever you're asking questions, please take a picture of what you are asking, more especially if you're asking me on WhatsApp, because sometimes I'm not home, then I want to respond to you, but I can't because I really don't know what you're talking about. Thank you very much, guys. I hope you enjoyed the video. If you have any question, please contact me. Thank you. Bye.